Welcome to Lesson 1, Factoring Polynomials. To factor polynomials, first we must understand what the word factors mean. So factors are numbers or expressions that we multiply together to get another number or expression. So for whole numbers, in this example, we have 4 times 2 is equal to 8. We can say that 4 and 2 are factors of 8. But a whole number can also have many factors. In this example we have here, what are the factors of 18? So we can see here that 1 times 18 is equal to 18. So 1 and 18 are factors of 18. We can also say that 2 times 9 is equal to 18. So 2 and 9 are also factors of 18. And lastly, we can say that 3 times 6 is still equal to 18. Therefore, 3 and 6 are factors of 18 as well. So, therefore, 1, 2, 3, 6, 9, and 18 are all factors of 18. Now that you know what the word factor means, let's go to the word factoring. Factoring is the process of finding the factors. It can be thought of as splitting an expression into a multiplication of simpler expressions. There are different ways in which we can factor expressions. Let's take a look at one example. Here we can see quantity x plus 2 multiplied by quantity x plus 3 is equal to x squared plus 5x plus 6. We can see here that the two quantities or the two factors here, x plus 2 and x plus 3, are factors of the expression x squared plus 5x plus 6. Meaning, if you multiply these two factors, you will get the expression x squared plus 5x plus 6. Let's look at another example on how to factor expressions. So in this example, we have to factor 3y plus 6. To do that, we first need to get the factors of each term. So the factor for 3y are 3 times y. The factors of 6 are 2 times 3. Now, looking at both of their factors, we can see that they have a common factor, which is 3. So we can factor the whole expression into 3y plus 6 is equal to, the factors are 3 and 2 plus y. So 3y plus 6 has been factored into 3 and 2 plus y. Factoring can also be thought of as the opposite of expanding, as shown in the illustration here. Now, before you can factor polynomials, you need to have these two skills. First one is finding the greatest common factor, or the GCF, and applying the distributive property of equality. First, let's start with the greatest common factor, or the GCF. The greatest common factor of two numbers is the greatest integer that is a factor of both numbers. To find the GCF of two or more monomials, we simply write the complete factorization of each monomial and find the common factors as shown in the following. So in example 3, we need to find the GCF of 10b cubed and 4b. To do that, we first need to find the factors of 10b cubed. So what are the factors of 10b cubed? We have 2 times 5 times b times b times b. Next, we need to find the factors of 4b. So what are the factors of 4b? We have here 2 times 2 times b. Notice that 10b cubed and 4b have one factor of 2 and one factor of b in common. So there's one b here, one b as well here, one factor of 2 and another factor of 2 here. Therefore, the GCF of 10b cubed and 4b is 2 times b, or 2b. Let's take a look at another example. Find the GCF of 10v cubed, 15v to the power of 7, and 30v to the power of 5. To do that, first we need to find the factors for each term. The factors for 10v cubed are 2 times 5 times v times v times v. The factors of 15v to the power of 7 are 3 times 5 times v times v times v times v times v times v times v. And the factors of 30v to the power of 5 are 3 times 5 times 2 times v times v times v times v times v. Now looking at our solution here, we can see that all three terms have the factor 5 in common and 3 factors of v in common. So 1, 2, 3, 1, 2, 3, 1, 2, and 3. So therefore, the GCF of 10v cubed, 15v to the power of 7, and 30v to the power of 5 is 5v cubed. Next, let's take a look at the distributive property of equality. During your lower years, you have learned how to solve problems such as these by using the distributive property. So we have here 2 multiplied to quantity 6 plus 2. All you have to do is distribute 2 to both 6 and 2, giving you 2 times 6 plus 2 times 2. If we simplify that, we will get 12 plus 4 or 16. By distributing the number 2, we are able to come up with the answer, which is 16. The same principle applies for polynomials. Take a look at the example below. So we have here 2a multiplied to quantity 3b plus 5. So by distributing 2a to both 3b and 5, we will get 2a times 3b plus 2a times 5. We are able to multiply the common factor 2a to each term in the binomial by using the distributive property. However, the distributive property is an equality. The reverse of this process is also true. So if you say 2a times 3b plus 2a times 5, it is still equal to 2a times quantity 3b plus 5. Now to recap, you have learned today what are factors, what is factoring, finding the greatest common factor, and applying the distributive property of equality. For lesson 2, we will have the common monomial factoring, which will apply finding the greatest common factor and the distributive property. So see you there.